This is comparing and scaling problem 3.4. These are actually the notes that I did with my students in class prior to this problem. This information is on page 37 in their textbook. So we were comparing two different stores' sale prices. Corner Market has 7 pasta boxes for $6, and Superfoods has 6 pasta boxes for $5. Assuming these are the same brand pasta boxes and same amount, same quantity, really we're just comparing the prices. So then it goes on to say that in trying to determine the better buy, Dario divided 7 by 6 and got this value. So 7 divided by 6, and he gets this value. This particular number, I pointed out to students that 7 is really an infinitely repeating 6, but this particular scientific calculator truncates and it automatically rounds for you when there's a repeated value like this. Goes on to say he then divided 6 by 7 and got this value, and he was confused. Question is, what do these numbers tell you about the price of the boxes of pasta at Corner Market? So we'll look at the first one that he did, and the secret in all of these is label, label, label. So first he did 7 divided by 6. When we're labeling, it's important to put down what it is that we're talking about. This is 7 pasta boxes. This value is the $6. And right now I'm doing this for Corner Market. In this, we're looking at a unit rate. And this $6 as a unit rate, we're wanting to know how many boxes we get for $1. The process to go from 6 to 1, if we divide that by that same amount, by 6, then we get $1. If the $6 are divided into 6 groups, the 7 pasta boxes also get divided into 6 groups. And that's where we get that value of 1.1 with an infinite repeating 6. That's the number of boxes. So what this tells us is approximately, on average, you get 1.17 pasta boxes for every dollar you spend. And the short way of writing that, we just say about 1.17 boxes per dollar. Now, a little bit on rounding. If we round this number to the nearest whole, we could say it's about 1. We could round this number to the nearest tenth, and it would be about 1.2. And then this is rounding it to the nearest hundredth. Now, when we compare that to Superfoods, we're looking at their prices, and Superfoods has 6 pasta boxes for $5. So the pasta boxes are the numbers that we had on top. The number on the bottom was the dollars. And again, we're wanting to compare how much is it for, or how many boxes do we get for every dollar we spend. So if we divide 5 by 5, we get 1. We divide 6 by the 5 also, and we get 1.2 boxes. So the labeling needs to stay in the right places. What that tells us is that on average, you get 1.2 pasta boxes for every dollar you spend. And the short way of writing that, 1.2 boxes per dollar. Now in comparing these, if we're spending $1, we get more boxes of the pasta at Superfoods than we get at Corner Market. The reason I did this additional rounding up here, if we had rounded to the nearest whole box, we would be comparing one box to one box, and it would give the impression that they are the same price. If we rounded to the nearest tenth on this first one, we could be comparing 1.2 to 1.2 boxes, and they would appear to be the same value. However, by comparing to the nearest hundredth, now we're looking at two values that are noticeably different. And when we compare those two values, 1.17 and 1.2, we can add a 0 there and see that we're comparing really 1.17 and 1.20. This is the larger amount. So because of that, we would have the conclusion that this is the better buy. The reason, you get more pasta boxes for every dollar. Now, in comparison, if we switch that ratio around, and rather than doing pasta boxes on the top and dollars on the bottom, if we put the dollars on the top and the number of pasta boxes on the bottom, we are now making a different comparison. In this one, if we scale the 7 pasta boxes down to 1 pasta box, we're answering the question of how much does it cost for 1 box of pasta. To scale 7 down to 1, it's dividing by 7. It's always dividing by that same value when we're wanting to turn it into 1. So if we divide the 6 by 7 also, that was the other equation that Dario did. Okay, I'm now indicating this is approximately, and I'm just going to write the whole number in that calculator and label it as the dollars. So what this tells us is that on average, it cost, now I'm rounding it to the nearest penny, so it's about 86, because that 7 makes it closer to 86 cents than it does 85 cents for 1 box of pasta. Or simply 86 cents per box. For Superfoods, using their numbers, 6 pasta boxes and $5, the dollar amount we want to put on top so we have an equal comparison, the number of pasta boxes on the bottom, and again, we're wanting to know how much it costs for 1 box, so we need to scale this down to 1 box. And again, it's always dividing by that same value. So 6 divided by 6 to get the 1. And if we divide the bottom part of the ratio by 6, we have to divide the top part of the ratio by 6 also. 5 divided by 6 is 0.83 repeating. And that is, again, the cost in dollars. So on average, and we don't really have to write that for this one. It makes more sense to say on average for the number of boxes because we can't have half a box or partial boxes. But here it would be $83 approximately. For 1 box of pasta. And as a quick way of saying that, 83 cents per box. Now comparing the better buy. This time we're looking at 36 cents per box compared to 83 cents per box. It cost more per one box, less per one box, therefore this is the better buy. So in one of these ratios, we're looking for the higher number, and on one of these, we're looking for the lower number. So the greater number of boxes for every $1, or the least amount of cost per box. And that would be it.